Look at this. If the electronic configuration of an element is 1s2, 2s2, 2p5, how many unpaired electrons are there? How many unpaired electrons are there? You know, electrons behave like lovers. They are always trying to be in pairs. But unfortunately, some electrons are not in pairs. They are single. And because of that singlehood, the atoms that have these electrons become unstable. So this question is saying, how many electrons are unpaired? How many singles there? How many unmarried electrons are in the atom? Okay. The electronic configuration is 1s2, 2s2, 2p6, sorry, 2p5. 1 here means first shell, like this. This is the nucleus, first shell. 2 here means 2 electrons. This 2 at the back means second shell. 2 electrons in pairs. 5 electrons. You see it? You see it? So this is the atom showing 2 shells. But this time around, to actually know the electrons that are single, we don't need to draw the shells. What we need to draw is called the orbital diagram. Remember, I was mentioning first shell, 2 electrons. Second shell, 2 electrons. Second shell, 5 electrons, making it 7 electrons. I did not tell you the meaning of S and P. These are the orbitals that we need to represent. How do we do that? S orbital is represented with a square, like this. So 1s2. This is another S, represented with a square. But P orbital is called degenerate orbitals. It has 3 squares in 1. So it is represented like this. 3 squares in 1. You see? So now, this 1s orbital has 2 electrons. They are paired immediately. They are paired. Another S has 2 electrons. They will be paired too. But this P is a degenerate orbital. And there is a law guiding the configuration of electrons inside the degenerate orbital. That law is called Horn's rule. Horn's rule states that when you are entering electrons into degenerate orbitals, these electrons will enter there singly before pairing takes place. Singly first. There are 5 electrons in P orbital. First one will enter here, single. Second one will not like to pair up. It will enter another orbital, single. Third one will go and become single here. Then fourth one will go to the beginning and pair up. Fifth one will go to this one and pair up. At the end of the day, how many electrons do we have? 2, 4, 6, 8, and 9. Looking at this orbital diagram, you will know that 1 electron there is not paired. It is single or unpaired. Therefore, the answer is here looking at us. A is the answer. If you found value in this video, click on the plus sign and follow this account.